I'm an inveterate teacher, so I want to make sure we're all in the same space. I'm 40 years in energy, and that's the issue that we're dealing with. So let's take a really quick primer on this. On the left are your energy sources, from solar down to petroleum. On the right are the different sectors, and that middle is that electricity generation. I call this my pasta chart. Go to the next slide. It's very confusing. This one shows what you're doing with all of those is either you're converting to heat or heat to electricity, or mostly for heat, and there's some kinetic energy in there as well. Next. But here we've got a problem, and this is why we're transitioning, right? We got the climate crisis. We have a fact that direct subsidies of $20+ billion a year and $650+ billion a year go indirectly to fossil fuels. And then we have the fact, I'm an environmental engineer, that 90% of air pollution is from fossil fuel burning, and that we have a very limited amount of people and resources, so we have to do this directly as fast as possible. Next slide. The other thing to keep, oops, nope, that's a different slide. Looks like the same, no, back to that little, oh no, you're right there, stop. Okay. All right, looks like another pasta chart, but only this one is different. This one takes those energy sources and says, well, which ones of those are creating those carbon emissions that we're having trouble with now? And so those are the ones we're going to have to look at. And if you look at the top 5, solar down to geothermal, good to go. We've got 3 in the bottom of the bottom 4 that we've got some issues with, and we know that. Okay, but we can see that the electricity sector is one of the biggest ones, and that's being taken care of. You heard about that. The industrial one is in New Mexico. It's mostly the oil and gas industry, and but here's the deal. A lot of it's not being shown on that chart. We have a lot of methane emissions that are not being shown on that chart, and that is a problem. And then we have the transportation sector. So we know what we've got to work on. The next thing we have to look on is how fast we're doing it. Because if we don't do it fast, take a look at that little graph down on the bottom left with the nice red line and the orange shading. Well, on the top is the net carbon. That's the route of carbon to years. And if you go slowly, like the red one, that's not going to cut it, because if you look at the bottom one, the green line, that's what's being called on by scientists so that we can avoid the worst of it. And so we see if we go too slow at the beginning, we're going to have a big chunk that we're going to have to make up for it. That's that orange shading. And so that's where we are. And methane, remember, is a greenhouse gas with very high warming potential, doesn't stay very long, unlike the carbon that stays for about 1,000 years in the cycle. Next slide. So there we have it again, that same chart. I want to just make sure we've got to get fast. And if we use hydrogen in our natural gas, it's worse than just going and using the natural gas. It's just worse. The next one, I think that might be it. Is that the last one?
Sure. Thank you. Athena, can you give us a little bit about your storage solutions?
Sure. All right, you got my slide up there. It's clean energy. Hot rocks could save humanity. Go on to the next slide. So everybody's been talking about the different kinds of storage that's available, and this one just talks about discharge time on the left versus the power range on the right, with the far right being 1 gigawatt or 1,000 megawatts. And you can see the different types up there. The top right corner, you can see the initials GTES. That stands for gigawatt hour thermal energy storage. And that's not something that anybody's talked about at the moment. So the next slide. Gigawatt hour thermal energy storage basically does exactly what any energy storage does. It takes the electricity, and in this case, it's mostly talking about a geomaterial like rocks. All right, storing it. If it's in a large pile, you've got that whole small surface area to large volume issue. And then when it's needed, you dispatch it as heat. And then that heat can be used as heat, or it can be used as electricity. Or in some places, I've seen it used initially not as heat, but to make ice so they can be used for cooling later on. That's very big in your hot states like Arizona. Next. And then you could take a look at the levelized cost of storage and the capital expenditures when you're using rocks. If you're using a legacy gas plant, it really brings the price down. I won't get into that too much right now because the prices have changed all over the place. So next slide. But here's what I'd like to really be focusing on in our state, a couple things. We have an opportunity. If we can get long duration, or if we can get energy storage in places that there are peaker plants right now, it establishes some sort of environmental justice. So what you see on the left is New Mexico, and those circles represent the peaker plants and how big they are. That also represents pollution for the area. And on the kind of the grid in the middle, that shows how the population, the low income population and the minority population, how that is kind of compared to where the location of the peaker plants, with the top right being the highest low low economic and the highest minority. So we see we can do some true environmental justice if we can locate some of these in places that will remove the pollution as well as increase the base. Couple companies I'd like to mention for the thermal energy storage is Bren Miller. It's basing it on the concentrating solar power plant. That's the basis for the name of my company, but we just detached the concentrating solar part from it. And Bren Miller is working on utility scale. Another one that it might need some massaging is a local one, Keros. They're doing nuclear power, but I think they should also consider doing energy storage. And that's my 2 cents and 50 cents and $1, whatever you want to take it as. Next slide. I think that's just my information.
Okay. Thank you, Athena, for sharing your thoughts on this story.